Good to be here back in Bangalore. I went to college here, Indian Institute of Science. So good to be back in Bangalore after a long time. My goal this afternoon is to kind of give you a perspective on the databases that we have created to help you deliver very innovative and interesting applications for your customers. We'll likely go deep dive into a couple of areas. We'll cover some technical aspects, some user aspects. And as we go through it, we'll also make this, towards the end, very interactive. Ask away any questions. So the headlines, typically you hear often in the news that there are companies that are launching these incredible applications. WeatherBug, for example, serves millions of users with real-time updates. Samsung, if you bought a Samsung TV and are using the Smart Hub application, it runs on one of the AWS services. Flipboard, really cool social magazine application that's running on iPad, iPod, and Android devices, delivers billions of pages for end users. How do they do it? How do they do it on the cloud? How could you build applications like that? What techniques and traps are available so that you can avoid the traps, use the techniques? They use DynamoDB. The first two use DynamoDB, and the next two use Amazon RDS. We'll talk about what this entails in terms of making use of these technologies for your applications. Oftentimes on the internet, I hear and I often get asked questions on the debate between SQL versus NoSQL. It's almost like Congress versus BJP or whatever the local politics are. Our view on this is we don't take a point of view on yes or no. Classic Amazon perspective is we want to give you choices. We come from the retail background, so the more choices we have, the more selection we have, the better it is for our customers. Ultimately, it comes down to not the technical debate of which is right or which is not. It comes down to focusing on your applications. So then the question is, how do I do that? There are several criteria that makes up how you focus on your application, some of which include, for example, the first question you might ask yourself is, what kind of application is this? Is this an internet scale application that serves millions of users with billions of pages? Or is this a complex business process application that has multiple entities all interlinked with one another? Next question you might ask yourself is, are there transactions involved? How complicated are they? Are they single item transactions? Or are they multi-step transactions? Third question you might ask yourself is, scale-wise, how does it scale? Who wants to manage the scale? Do you want to manage the scale on your own? Or do you want the database to manage the scale for you? From an availability perspective, again, a big question, right? So most of us are very used to deploying database applications where we take control of the availability. We define the primary, we define the secondary, we define the policy by which we will flip from primary to secondary. You could think about a world where it's completely transparent to you. You don't even need to think about what failover means. The database is pretty much available all the time. These are questions that you can ask yourself and choose the right technology that uses both. It's possible to use both. In fact, probably the best of both worlds, particularly for internet and mobile applications, is in using both. With that said, let me spend a few minutes on focusing on your application from DynamoDB perspective. The emphasis is really on your app. What is DynamoDB? By show of hands, how many of you have heard of DynamoDB? Wow, 10, 15, 20 people, maybe 100, I don't know. My goal is to make sure that every one of you at least kind of know what DynamoDB is, and how many of you are actually using DynamoDB by show of hands? Look at this gentleman, smart one in the crowd. My goal is to, in addition to him, have all of you, at least some of you, try DynamoDB. DynamoDB is a managed NoSQL database service. What that means is it does not provide you a SQL interface, but it provides you a much simpler web native interface, allows you to store any amount of data. Tables in DynamoDB are basically bottomless. You could pretty much store any amount of data. You can serve any level of traffic. You can start with 10 users, go to 100 users, 1,000 users, and million users. Just dial up the volume as you would do on your stereo server. All of this is available to you without any operational burden. That's a very important point. Here you are just focusing on your application, not on the operational details of running a database. In addition, you actually get consistent high performance. What's very impressive about DynamoDB is the fact that it delivers single-digit millisecond by itself is amazing, but it does so as you scale the database from 1 user to million users, 1 gigabyte to hundreds of gigabytes to terabyte, and it delivers you consistent performance and predictable performance, single-digit millisecond latencies. This is possible because we use solid-state drives behind the scenes. We'll talk a lot more about how we achieve that. We also give you a very flexible data model. In the traditional relational world, you would have probably defined a table, and once you define the table and roll out your application, if your world changes, and if you have to add additional column or additional attributes, you would have to go through a change that required you to have maybe possibly take a downtime. With DynamoDB, it's a very flexible schema-less database. Everything is a key value pair. So you don't need to think about a schema. You can get going and tweak your application as you go along. It also gives you unlimited storage, virtually unlimited storage. There is no size limit, as I described to you earlier. You just start with what is convenient and necessary for you, and you can get going after that. By the way, there is no downtime involved. Practically, DynamoDB hasn't gone down from what I can know. From a durability perspective, a lot of people often ask us the question, hey, NoSQL databases, are they as durable as relational databases? When I commit something to the database, does it get written to the disk? The short answer is yes. It's consistent, and we confirm the write only after we commit the write to at least 2 of the 3 places where we replicate the data. We replicate the data across multiple data centers to provide a high availability, and you don't need to think about any availability zones, setting up primary, secondary, all of that. It's all done without any operational burden for you. So what's possible with DynamoDB? Let's look at what we are able to achieve. Here's a pattern. The red lines that you see are typical seasonal patterns of demand on our Amazon.com servers. Typically what we would have done is to provision for peak with some buffer. The red line that you see at the top is what the normal provisioning would have been. With technology like DynamoDB, what we are able to do is provision on demand. It's almost like when you ask for coffee, somebody brings you coffee kind of thing. Quite literally, you do it as you go along, and you only provision for the peak when you need to, and once you are done with the peak, you can actually reduce the traffic, reduce the load, so you can save money from an overall operational perspective. So then you might be wondering, hey, sounds too good to be true, how do I get this? There are 2 decisions that you need to make, of course, in addition to deciding to use DynamoDB. 2 decisions, 3 clicks. After that, you are ready to use one of the most interesting technologies of our time. First decision is you have to decide what a primary key is. What key do you want to use? Second decision is what level of throughput would you like to have? Again, some of us may have actually relied on database and storage experts to devise or tell us what throughput means. We'll talk a little bit about what that means. This is something you as an innovator, you as an engineer, you as a programmer can decide for yourself what your application should do. By the way, this is not like a commitment set in stone. You can change it as you go along. Let me give you a quick illustration of what DynamoDB looks like. All of us are familiar with table structures in relational world. So let me take an example of an ordered table. What you see below is an ordered table that contains of 2 rows. Each row in DynamoDB is called an item. Now I'm not referring to a Hollywood or a Bollywood item. It's really just a database item. So first one is an ID. Second one is a date, and that can be a range key. Third one is a price. Very simple. Everything that you declare and say, here's my attribute, here's my value. The values can be either a string, Unicode binary, Unicode string, or UTF binary, or a number. And once you create the schema, you don't have to get stuck with the schema. You can create additional items that have more attributes or less attributes. It's really a schemaless representation. Your primary key can be a hash key or a range key. This is it. It's about as simple as it gets from a conceptual point of view. All items are indexed by primary key, so you always will be able to go get the item that you're looking for based on the primary key that you specify. For example, in this case, typically in the relational database, if you wanted to know, item 100's price or the order value, you would have issued a select statement. Select from table where ID equals 100, right? Select total from a table where ID equals 100. Here, that operation would be simply a way of using the primary key and doing a get operation. We'll talk a little bit about it. Think about everything that you need to do with the database in terms of reads, and you typically think about it in terms of reads and updates. Here you think in terms of reads and writes, right? So for example, a select statement might be just one read. An insert statement might be just one write. An update statement might be two reads and a write. This is kind of how you think about database operations from a select, insert, and update perspective. Once you get that clear in your head, it's very easy to understand what provisioned IOPS mean. What it is you're asking the database to reserve a capacity, much like the way you would use a reservation system to reserve a ticket to go from, say, Bangalore to Chennai or something like that. You tell the database, I want this many reads, I want this many writes. Programmatically, you can change that. The price you pay is not based on number of users you have, number of licenses you have. It's quite simply what you provisioned as a throughput. For example, here you might say, I need, the write throughput might be the item size, which could be up to 1 kilobyte, times number of writes that you need in your database. You only pay a penny per hour for every 10 write units. For every 100 reads, you only pay a penny per hour. It's incredibly cheap. If you had to try this on your own, it will cost you way more than what we are showing you here. All your writes are consistent. So once you decide what your provision throughput is from a database perspective, automatically we do increment and decrement. So it's easy for you to know that your writes are very consistent. Transactions, this is another question we get often asked. Can I do multi-table transactions? Because there is no idea of relationship between tables, transactions are at an item level. At that level, all your puts and updates are completely ACID. So those of you who are familiar with relational databases can appreciate that those updates are completely ACID. From an overall throughput perspective, DynamoDB offers two different models. One is a strongly consistent model, or the second one is an eventually consistent model. In a strongly consistent model, we serve you the request so that all reads are consistent across your sessions. Whereas an eventually consistent model serves the request from the secondaries that are being copied to. Eventually the data will get consistent. There may be slight inconsistency if you happen to be within the narrow, but for many applications that is sufficient, particularly for online social media type applications. For transactional type applications, you might want to use a strongly consistent model. For much more of a chatty applications, you might want to use an eventually consistent model. Regardless of which model you choose, the latency expectations are the same. You can pretty much mix and match at read time. However, all of them have single-digit millisecond latencies. So we talked about two decisions. Now let's look at the 3 clicks. First click, you specify the table name, you specify the primary key. Second click, you specify the throughput that you would like to make available for your database operations. And then the third click, you are ready to set the alarms for your database so that when you are close to storage or when you are close to your throughput, you can be notified. With those 3 clicks and those 2 decisions, you are ready to go. You are ready to use. You are ready to build a table from a single API call. Quite simply provision that table, and then you can pretty much develop. Literally, you don't need to do anything to go to production, and you can go to scale. That database, you don't have to go through a full life cycle of testing, monitoring, and all of that. You can quite literally go from development, test, scale, production, all in one sweep. With that stated, now let's say you got very successful, much like the way Flipboard did. You created your application, people love it, and you went from 1,000 users to 10,000 users tomorrow. What do? In a typical model, you'd be calling frantically your vendor, asking for more storage, more database licenses, more operations, trying to set this up, and load balancing, sharding, and all of that. Here, you go to the console and say, hey, my load is increasing, dial it up, done. 2 weeks later, traffic died, and you are now down to 1,000 users again, dial it back down. It's exactly like how you would use your air conditioning at home. From a security and authentication perspective, we provide you session-based authentication to minimize the latency. Second, we also use the security token service, so you can actually make use of your secure policies. Last but not least, we integrate with IAM. Those of you who are using IAM, you can carry forward those identity and access management policies into DynamoDB. Plenty of monitoring options are available to you. So you can use CloudWatch metrics for latency, consumed reads, consumed writes, so that you can watch your pricing and what errors we ran into. When you go over your provision throughput, we actually throttle you so your application may stall. We don't drop your connections, we don't drop your writes. It may take longer than the single-digit millisecond latency, and you can see when we are throttling. That way you can watch it and go increase the throughput as you need it. If you are a Java programmer, you can make use of the technology. If you're a .NET programmer, you can make use of this technology. Pretty much we have libraries, mappers, and templates available for a variety of programming languages. We try to make it very easy for you. So you say, well, all of this sounds good. What did I give up? Well, you can call your mom and tell her, Mom, I lost my schema, because you don't need to worry about schema. You can also tell her you can't find your joins because there are no joins. You don't need to worry about joining tables and things like that. It does simplify your data model quite a bit. So if you really have web scale application that doesn't require any joins, you'll be very happy with this. Then the next question might be, well, now that I understand it, how hard or how easy it is to program? The interesting thing about DynamoDB is the API is really small in terms of footprint, and it's perfectly formed. The entire API for DynamoDB sits on this slide right here. So you can do create table, update table, delete table as a way of managing your database. You can query or scan. Query would be individual items. Scan would be the equivalent of full table scan, like a select star kind of thing. Your get item is the equivalent of select. Your put item is the equivalent of insert. Your update item is the equivalent of update. And delete is the equivalent of delete. Very simple, straightforward. You can also do multiple reads and multiple writes. Batch get item and batch put item gets you that. Quite literally, within that API set, you are ready to go use one of the most interesting internet technologies available today. You can retrieve items by specifying a key. We talked earlier about this. Or you can also specify conditions. You can say ID greater than 100 or ID greater than 100 but less than 200. All the options that you would typically use SQL statements for, they are available to you. You can also do counts, top and bottom end values. Responses, if they are larger than what your array is, then they are paged so that you can retrieve it progressively. Here are a couple of thoughts in terms of mapping relationships. Oftentimes, we get asked, hey, you are asking me to give up joins, but I need an application that has this. You would do this by using composite keys, and you would effectively create two tables where you would do the subselect and iterate through the select on the other one. Very easy to do. It's just a simple equivalent of VLOOKUP in Excel. So most of you should be very familiar with it. Some of you have asked us, hey, what are the limits? My item size might be greater than 64K. What if I have a document format that's greater than that? What we have seen, and we'll talk a little bit later about this, is customers have actually used fairly large items, except they actually use the pointer in DynamoDB and the objects in S3. Cloud Drive, if you're familiar with Cloud Drive, they use DynamoDB. The pointer to your drive in terms of music files and other things are stored in DynamoDB, but the files themselves are stored in S3. That way you get the best of both worlds. You get the super fast, ultra low latency DynamoDB performance in terms of user operations, and when the user decides to pull something down, you can get it from a highly durable store like S3. Currently we don't support secondary indices, but you can create on your own. Time series data, people have often asked us about how do I handle time series data? There is new data that's very hot that we frequently access. There is old data that we don't as frequently access. Here's one way to think about it. You can use the most current one with a high throughput, and then the least recently used or least frequently used with lower throughput. You can manage your spend and your application characteristics based on quite simply managing your throughput. Cloud Drive, I talked about this. It's an interesting application. They actually went to production even before we launched DynamoDB. It's a pretty interesting, awesome application. They use DynamoDB to show the users what's in your Cloud Drive. Find me all the music albums that are stored in my drive is a question that they quite simply answer very fast. But once you pick the album that you want, they fetch it from S3 from a storage perspective. There are hundreds of other companies that use it. Not only Cloud Drive, you can look at Electronic Arts. Earth Networks earlier talked about WeatherBug. They produce an application that's very interesting. Gumi, a video game maker, is using DynamoDB. So this technology is not, even though it's relatively new from a launch perspective, it's something that we have perfected over the last 5-6 years from the original Amazon Dynamo paper that Dr. Vogels and my colleague Swami created. Now that's available to you in the form of a very convenient low-cost option for you to build your own innovative applications. Hopefully that gives you a perspective on what our NoSQL offering is. Now that I've told you a lot of good things about NoSQL, it's time for me to turn the tables and say, you know what? Relational is not bad after all. If you're comfortable with it, let's see how well we can make that easy for you, right? So again, the purpose of this technique or technology is not to talk about relational versus non-relational. It's really about focusing on your application, right? So typical database might have 3 tiers. There is a top load balancer, there is an application tier, there is a database tier. Really what you want to do as an innovator, as an engineer, as a client-facing software developer, you want to focus on the application, which is where your innovation is. You want to spend very little time on database, which is necessary, but that's not the reason why you exist. Here are the complicated things that you have to do. You have to design schema, you have to patch the software, you have to ask for backup, you have to ask for recovery, you have to construct queries, you have to do software upgrades. It's a messy world if you're a software engineer using relational technology. Let's just use it and clean it up a little bit. All the things that's on the left-hand side are the reason that you are adding value to your customers. Schema design, that's your innovation. Write queries, optimizing the queries, making sure things that drive value for your customers, therefore delivers money for you. That's focusing on the buck. And you can offload the mug, migrating, backup and recovery, all the mug items, you can just offload it. Here is Forrester's view of the world. They show nearly 40% of time is spent by programmers on various aspects of database. My database crashed, it's not performing, it's slow, I can't get things done. Just a lot of things that are a waste of time. Instead, by shifting to a technology like Amazon RDS, you get that 40% back. It's as though in a week you got 2 days back for you to focus on your application. Let's do a quick introduction. What is RDS? RDS is a fully managed relational database service. What we provide to you is we don't take sides on which database is the right database for you. We give you a choice of database engines. We make it ultra simple, super easy for you to deploy. We make it very easy for you to operate and run it over time. What's more important is we make it very, very easy for you to scale. We'll talk about it. We also make it incredibly easy for you to make it reliable. Quite literally, a single push button, that's all required for you to create a super redundant, super reliable database engine. And on top of all of this, it's very cost effective. We'll talk a little bit more about how that works. Here are choice of engines. You can run MySQL, those of you who are familiar with that engine. If you are familiar with Oracle or SQL Server, you can continue to use it. So those of you who want to play with SQL Server 2012, go ahead and check out aws.amazon.com/RDS, and SQL Server 2012 Express is available for you up to 1 year free of charge. Build your application, test it, scale it up, and see what it does. Let's say you are an Oracle user and you want to take advantage of it. First of all, a fully licensed Oracle database is available to you for about $30 a month. But if you are an Oracle Technology Alliance partner and you want to bring your own license, you can go ahead and be part of our RDS free tier offering and make use of that for a while, close to a year. And if you're getting started with MySQL, again, we just recently, I believe this Monday, announced RDS MySQL free tier. You get up to 1 year free of charge. Build your application and see what it does for you. How do you get started? Once you decide that you want to be, there are 3 decisions that you would make and a couple of clicks. We'll look at that. First decision is, which database engine do I want to build your application on? Second decision is, how much instance do I want to provide? How big an instance do I want to provide? And how much storage do I want to provide? This is not like getting married. So once you make up your mind, you can still change it later on. You can go big. Availability, yes. You can make it available initially as a single AZ or go into multi-AZ. We'll talk a little bit more about. First choice, pick up your MySQL or Oracle or SQL Server version. Second choice, provide the instance size. You can go from micro all the way to 4XL. More instance choices will be available in the future. You can provision the storage from 5 GB up to 1 TB. You can start with 5 GB, make it 50 GB, go to 500 GB just by the click of a mouse. That is an online operation. You don't have to take down your database. How many of you can upgrade your storage server without taking an outage? That's what I thought. Here, it's simply an online operation. So we allow you to upgrade your storage server, go from 5 GB up to 1 TB. Then you can launch your instance. Off you go. Now you can start issuing select star applications. 3 decisions, a few click, it's ready for use, ready for development. Some customers have asked, hey, I run this production application, I run into a particular problem with 5 million rows, 10 million rows, I cannot reproduce it in my test and development center. Why? Because I don't have the same production server. With RDS, that's very simple. You snapshot that database, which takes a couple of minutes, and you provision a new instance completely away from your production, and you now have an exact copy of your production application ready to go. After you're done with the testing, you can just delete it, and nobody got hurt. It's that simple. Then you can scale. You started with M1 small, and you really got busy with your users signing up. You can go to M1 large. Next week, you got even more popular. Go to M2 2XL. The following week, you got even more popular. Go to M2 4XL. Very easy to do, from scale to production. How do we remove the muck? You have to think in terms of what makes me productive, what drives my database performance, what gives me data protection. First, as a managed service, we make database administration our problem, not yours. We make software installation our problem, not yours. We manage security updates, so you don't have to. We provision storage and scale it up as you demand, so that you don't have to worry about dealing with storage vendors. We patch the instances, so you don't have to worry about patching them. Really, this is about liberating the time that you can have to build the application, manage the application, drive value for your customers. Backups and snapshots. We automatically take a backup every night at a time window that you specify, and we also back up your bin logs or your log files every 5 minutes. This way, if you ever wanted to go back in time, it's almost like going back in time. Your database now has a time machine available for it. You can go back in any point in time and say, an hour ago, 2 hours ago, down to a second, that's the database that I want. And we'll give you a new instance at that point. It's super effective in terms of recovery as well. Here are all the things that we do for you. We talked about productivity and offloading the muck. Multiple databases per instance. You can have standard user accounts. You can use your favorite front-end applications. You can import and export data. You can do diagnostics. You can use native MySQL replication to provide read replicas. All of this is available to you. The only thing that you give up is super user or shell access to the engine. We do that because we think about security. We don't want anyone else to accidentally have access to your data, so we block access to the instance. But we give you access to the instance via our APIs and our front-end tools. That makes it near zero administration. You don't have to think about patching. You don't have to think about upgrades. You don't have to worry about monitoring. We give you CloudWatch metrics. You say, this all sounds good. Now that I have built this application, my customers love it, my end users love it, I need to go production. How do I do that? Quite literally, you just go to the console. Right there, you say multi-AZ deployment. Make that database a multi-AZ deployment. What we do at that point is provision an exact same instance in a different availability zone. Earlier, several of the speakers talked about it. An availability zone, from an Amazon perspective, is a complete independent data center that's away from your primary data center, connected by a high-speed network. When you make this multi-AZ option available, we automatically provision that instance. We do synchronous replication between them. What does that mean? When you commit a transaction on your primary, we immediately replicate that over to the secondary, so your data is always consistent. Second, we also allow you to, in case of a failure, automatically fail over to the secondary within 2 to 3 minutes. So your application can be highly reliable. We talked about scale, push-button scale. I said many times, you can go from 5 gigabytes to 1 terabyte. It's a complete online operation. You don't have to stop your application. You can scale your instance from small to 4XL. You will take a 2-minute brief maintenance window type outage, but you get much better I/O if you go to the higher instance. As of last week, we also announced RDS provisioned IOPS. For those of you who write highly demanding OLTP applications, I encourage you to take a look at it. And it's a fantastic new technology that you tell us, similar to DynamoDB, you tell us what amount of IOPS you would like your database to have. 1,000 IOPS, 2,000, 10,000. We provision that and we maintain that within a very short margin of error. That makes your application architecture incredibly simple. Previously, you might have added a cache or a read replica or separated the database into multiple instances, largely to overcome performance bottlenecks. You can now start to consolidate them. You can have lesser moving parts. Really, really interesting technology. On top of it, you can also add Elastic Cache. Elastic Cache is a fully managed Memcache service that drives service of read requests, which you can put in front of RDS. From a data protection perspective, all of you, I know database is very important, and data is the reason why we build database applications. From a data protection perspective, we take daily backups. We back up all the way, we back up all your bin logs every 5 minutes, and you can keep the daily backups up to 35 days. And you can recover anything up to 5 minutes. So quite literally, you can go back any time prior to 5 minutes, and you can pretty much get anything you want. We also give you complete access to all the engines that we have in VPC with SSL encryption available and database security groups. So fundamentally, we care about security a lot. That's our first and principal primary tenet we believe in. And we give you a ton of choices to make sure your database is protected and well managed. Who is using it? So we talked a little bit about Samsung, right? Samsung is using this application along with EC2 and a bunch of other services. They deliver an incredibly innovative, creative new application along with their TV. In doing so, not only are they raising the bar in terms of innovation and television experience, they are also reducing their cost. This is benefits twice as much as the first one. They are not only delivering you a great TV, they are letting it connect to the internet, they are letting you choose channels and keeping track of your preferences, and at the same time, they are saving costs. So the question is it idli or dosa or puri? You could go with SQL or no SQL. The real idea here is focus on your application. Here are a number of customers that are currently using RDS. With that stated, I know many of you have questions, so we'll spend some time, about 10 minutes, taking some questions. Before I take that, I wanted to thank you for taking your time. I know time is a precious commodity, so I appreciate you spending it with me. And don't forget, we have free tier and free trial available. So do go to DynamoDB or RDS on the web and try it out. The best way to learn is to get on the bike and fall a few times.
Hi, this is Vignesh.
Questions?
My question is, can I deploy my data warehouse application based on SQL Server into RDS, and which can also scale into multiple machines easily?
So good question. So the question is, can I deploy my data warehouse application on RDS with multiple machines? The short answer is yes, but maybe there is a yes followed by a but. Yes, you can partition the data across multiple machines. At the application tier level, you would distribute the queries as you choose. If you are going to use data warehouse, I would strongly encourage you to look at provisioned IOPS. Provisioned IOPS gives you nearly, in our internal tests, we see it providing 7 to 10 times better performance. So definitely from a readability perspective, you want to use provisioned IOPS. You can do it. I also want you to recognize that SQL Server today does not support the multi-AZ option. Because this is a data warehousing application and you take daily backups and frequent snapshots, you should be fine with being able to recover. And it's not a OLTP type application. So all in all, I think it's feasible. Depends on your data size and your partitioning architecture. I would start with a small data set, try it out, and then go from there.
So can I use all the tools that comes with SQL Server, like SSIS?
Yes. So SSIS, that one particularly I'm not familiar with, but I know Visual Studio, Management Server for SQL Server, SSMS. I mean, there are lots of acronyms. I have personally used a couple of them. I just don't know what SSIS is. But
ETL tool. That's an ETL tool.
Right. So you should be able to use it. You should. I mean, the way you should think of the RDS engine, SQL Server engine, sitting in the cloud, to you and to your tools, it's an ODBC connection string. Once you set it up and you provide the authentication and the ODBC connection string to your tools, they should be able to do that, use it very easily.
Thank you.
Another question over here.
Yeah. From the databases that you have mentioned, I see that clearing one particular database missing, that is Postgres. Are there any plans to introduce PostgreSQL in AWS?
Good question. So the question is, are we planning to introduce Postgres? We constantly evaluate the list of choices our customers need. This is a feedback that we have heard, particularly I've heard many times in this trip. It's not something that we take lightly. So I'll go back and reassess with the team. Overall, our intent is to support the databases that our customers ask for the most. So if you have particular use case and need, there is a long-running discussion thread on AWS Forum. Please feel free to go there and kind of highlight why you need it and what you need. You will definitely see a response either from us or one of the product managers. And it's something that we will evaluate and support in the future.
How do you handle data corruption here? Like the item size you told 64K?
Yeah.
Here.
I see you. I see you. Yeah.
So the item size
you look like a giant light to me. So.
Okay.
Yeah.
the item size you told 64K and the pointer is here and the object is somewhere on S3.
Right.
So how do you handle the data corruption here? It might be data corrupted in the items. The logic in between the S3 and the 64K column size. So how do you handle this data corruption here?
So the question is, how do I handle data corruption between the pointer here and DynamoDB and S3? I would think the way you would actually deal with it is you would upload the larger item on S3, and the only operation you are doing is updating the record. Since DynamoDB is pretty available, so far we have not run into any data inconsistency issues. The best way to deal with it is for you to try it out. I don't think we'll run into data corruption issues, but we can take that question slightly offline if there are specific use cases. If you have run into it, please tell us or give us feedback on specific use case. We'll go dig into it. I'm not aware of a situation like that. Another question over here.
Yeah, if you want to upgrade from say MySQL 5 to 5.1,
yeah.
Will there be any downtimes?
Updating from MySQL 5 to 5.1, will there be any downtime? I don't believe version upgrades are automatically, I do not believe version upgrades are online operations because we have to restart the engine. There will be a short downtime. I think it will be of the order of maybe like 1 to 2 minutes. You don't have to worry about that being taken down during the day. You typically pick a maintenance window when you have the least amount of traffic, most likely middle of the night, sort of 1 a.m. kind of thing. And at that point, we'll automatically upgrade and restart the instance. You won't even notice. So you can announce to your users you have regular scheduled maintenance window. We don't take the whole maintenance window. If you give us 30 minutes, we often take as small as possible. So version upgrades, I don't believe, are online operations.
Hi.
Yes, sir.
Hello.
There's a question here.
Your IDS is about to do 1 terabyte.
Yeah.
Is it on the single site? If I do multiple joins, they happen on a single site, or if they do distribute 1 terabyte across different sites within the same zone?
So, very good question. The question is, RDS has a limit of 1 terabyte. How do I distribute? I want to reemphasize the point that this is 1 terabyte per database instance. I have customers today running multiple hundreds of terabytes because they use a partitioned architecture. And you can take a terabyte and distribute it on 4 nodes, or you can take 4 instances and provision up to 1 terabyte each. That will be 4 terabytes. The only thing is you would be managing that sharded partitioned architecture, which you seem to be familiar with, so it should be very straightforward. Who has the microphone?
I have it. I had the same question. So
answered.
Yeah, but again, your EBS limitation is 1 terabyte.
Yeah.
So we are using Postgres again with 1 terabyte. So is that a limitation because you don't manage the sharding?
No. I mean, so the question is, you're using Postgres, is 1 terabyte a limitation? Well, since we don't support Postgres, there is no limitation for you. So yes, so you could use Postgres on EC2, and you would be managing the partition yourself. Our goal, as we listen to customers, is many customers have asked for greater than 1 terabyte support. It's something that we are looking into. I can't give you an exact time frame right now, but you can anticipate Amazon is about convenience and scale and simplicity, so you can expect us to continue to raise the bar from a scale and performance perspective. You should hold us accountable for that. Yes, sir. You have a microphone?
As you mentioned, for RDS, we will be not having a direct access for instance. How to access the logs for the MySQL RDS? So
today we provide quite a few access. For example, we provide access to the slow query log and few other logs in the form of tables and things like that. But it is something, again, I've heard from multiple customers. We would like to work on, and we are currently thinking about a way to improve that experience for you. With that, let me once again thank you so much. Please don't forget to sign up for our free tier. It's free, so make use of it. And I appreciate you all spending time with me. I'll be available for additional questions.